Hello, this is Javier Moreno, and this is a tutorial about how to optimize Mistika performance. This video is organized like a reference guide. Here in the timecode index, you can find wherever you are interested and jump directly to that section. But if you have finished all the series in your streaming service and you are brave enough to watch the whole video in one go, here we go. As you can see in the index, first season is going to be about real-time playbacks and overall interactivity, and then there is more content about rendering and the use of external renderer managers. This is the Mistika engine for real-time playbacks. Mistika is going to first read frames, obviously, then decode the images, send it to the GPU for processing the effects, and then send it to the video output. This can be optimized in two ways. First thing is to process in parallel different frames, so each frame is going to be processing a different CPU core for more speed. In some cases, we can also decode frames in the GPU for the case of R3D or RA files. Then we apply the effects in the GPU and send it to the video output for playback. The other way that we can optimize is to do all these things at the same time. While the first frame is already visible in the monitor, next frames are in a queue already rendered, and next frames are processed in the GPU, and another packet of frames is already in the CPU to decode the images. And even more, one more part of the computer is already reading frames from disk for later decoding. Let's open the config tool. If we go to the codecs or performance options, we have all the list of parameters that we are going to use to control the engine. In advanced options, we are going to have some more. So we are going to use this mode because we want to comment about some of the extra parameters. All these parameters in the diagram in green color correspond to parameters in the config. The first parameter is maximum cache memory. This is a cache that is in RAM at this level. All the frames that are read from disk and decode are kept here, the recent frames. So if the GPU is processing effects and they need images that they were read before, they are still there. So we don't need to go through all the process of decoding and reading from disk. This is useful when you are working with one shot all the time. So you're gonna do playbacks again and again. The first time, as we can see in Mistika, is gonna be slow because there is no real time, but now in a second time the frames are already in the cache, so this is much faster. Of course, this parameter requires a lot of memory, so if you increase this value, be careful because this memory cannot be used for anything else, so you can run out of memory easily. So now we have the complete version of the diagram. There is one more thing. If we have an image on disk and we have this version, if there is a change in the image on disk because another application or background render make a change, we need to force a refresh. So because if not, we are going to use the old version all the time. To do this, we have a button in Mistika which is the flush cache. In this example, in another application, GIMP, I'm going to change the image. I'm going to apply a couple of filters, something simple, because the good thing if you are an engineer, not a colorist, is that you can make an image worse than the original and nobody's going to complain. And now in Mistika, after I save it with the same name, I'm going to press the flush cache button, and when I refresh the image, clicking the timeline or whatever, it's going to change. Next parameter is a playout ring buffer. Mistika always try to process images faster than real time, so it can have a buffer ahead in case that the system is slower than real time, it can use the buffer to go through that area of the timeline. It only works with video boards like Aja, Blackmagic, DVS. There is no buffer if you are using a playback to the graphics monitor. If we look at the monitor bar in Mistika, there are two numbers. The second one is the buffer, the ring buffer, and is the number of frames that are already processed in advance. This number is limited by the playout ring buffer value in the mconfig. This is the maximum number of frames that we render ahead. The other value at the left is the target frame rate. Normally it is the frame rate that we have defined for this video format. But if Mistika is not able to process enough frames per second, this is going to be a warning. It's going to be a lower number than it should. This is not necessarily a problem because we have the other ring buffer to compensate for this. So as long as we have enough frames in the ring buffer, the play is going to continue in real time from the point of view of the user. But if there is a point that the ring buffer is empty, we are going to see this message, the lost sync, which means we have lost the synchronization with audio because we have repeated some frames in the output. So Mistika will continue the playback, but this warning will stay there just to tell you that what you have been watching maybe is not correct. The last example, we lost sync because we started playback in a complicated point. But for these situations, we have another function, which is the Playbuffer. And this parameter here, the Playbuffer Threshold, is going to control the beginning of the playback. It's not going to start playback until this number of frames that we define in here is already pre-rendered and in the buffer. So we ensure, for example, for client sessions, we make sure that when you press playback, it's going to take a little, but it's going to work well. What we have to use in Mistika is this icon with the B. The Playbuffer has its own playback button, or Alt space, which is the hotkey. And then the playback is going to read all these frames, and then it's going to start once it's ready. At this point, we need to talk about one question that many users are asking is why we have two different playbacks in the visual editor, the composer and timeline shuttles. And the thing is, here, as you can see, the playback is slow, it's not real time. It's slower than what we were using in the timeline shuttle. If we go to the timeline shuttle, we go just to the first. This is a 4K clip with a framing effect, and we can see it's real time. We can watch the clip because this tutorial is very technical, so it's good to have some rest. The difference is because the visual editor is not optimized for playbacks. It is optimized for changing parameters, interactivity on a still frame, and so on. If we take a look at the structure, if we want to change the relief effect, which is the orange clip, what we can see, this branch is independent. It's not going to change while we adjust this effect. What is below the relief effect is not going to change, so we can catch also this part. And only the three upper effects, the relief and the two other effects on top, are the ones that need to be refreshed while we change a parameter. Let's select relief and start adjusting a parameter. And this is why what the visual editor is great for this kind of work, because it catches what is necessary. It's not catch in advance like the timeline playback. If we try to do the same in the timeline monitor, select the effect and change the parameter, we are going to see it's slower. We don't have the same level of interactivity like in the visual editor. Okay guys, the next part of the tutorial is gonna be very dense, so let's watch the final render and rest a little bit. Next part is about proxies. But forget about the proxies that you know from traditional applications like rendering half resolution versions. This is not normally the case. In Mistika, typically you are gonna read the full resolution images and create a proxy on the fly when it's needed. This is because in most cases reading images and decoding is fast. Only in the particular case of R3D, RE files, Sony, complicated codecs, it's worth it to reduce the resolution, but we can do it directly from the raw format, do extraction at half resolution, so we don't need to pre-render any particular proxy. If we don't use any reduce factor and the images are coming at full resolution, Mistika is going to create the proxy in this point. He's going to reduce the resolution just before passing the images to the GPU. What is typically slow is the processing of the effects on the GPU. So this is why we want to have half resolution only in this particular process. In Mistika, the proxy menu is in two places. It is in the record monitor menu, so we can activate it here, or we can activate it in the visual editor, but it is exactly the same button. If you activate it in one of them, it will be activated in the other one. At this moment, we are in full resolution. If I try to move the text, I see it's complicated because I don't have full control to the pixel that I want to place it. But if I change to low resolution proxy mode, it's very easy. I have full control. A more interesting mode is a dynamic mode. In the dynamic mode, it starts at full resolution. The moment I change any parameter, it's gonna switch to low resolution mode, and when I stop the modification, it's gonna switch back to full resolution automatically. Also, a playback is gonna do the same, switch to low resolution. When still mode, it's gonna change back to full resolution. And it also works in a timeline monitor. If I play back, it switches to low resolution, and when I stop, it comes back to full resolution. Next category is the parallel processing. Here we define how many frames do we process on each component of the computer at the same time. If we see these numbers, the zeros, they mean auto configuration. Any parameter here that is 0, Mistika will use basically the number of CPU threads, or it will divide for a factor. For example, the render options, they need to decode and encode at the same time, so they just have this number. The first value is the CPU cores, or virtual cores to be more exact, the number of CPU threads of the system. Probably you will never change it because this is just for auto detection. If you want to reduce the CPUs, just in case you have another application running at the same time and you want to make sure that Mistika is not going to use all the CPUs for itself, then you could reduce this number. Otherwise, don't change it. Next interesting value is the pipe units. This is related with the number of frames that we read from disk at the same time. This is good for optimizing the disk I/O, especially for uncompressed formats. But it's also related with the next parameter, the I/O threads. This other value is about the processing to process one frame on each CPU core at the same time. So basically, when you are in a basic mode, just changing the pipe units is gonna also change internally I/O threads, because you don't want the CPUs starving because there are no enough frames, or you don't want to read more frames that you can process. But there are cases that you want separate control for both. If you are not already sleeping maybe you have noticed that we have skipped one of the parameters, the multiple disk I/O. This is one of the cases. For example, let's say that we have this situation. Imagine that this circle is the hard disk and we have 2 clips. And then we need to read 1 packet of frames from one clip, 1 packet of frames from the other. If we think that this red monitor bar is the hard disk head, what we don't want to do is this, reading 1 frame from each clip. We don't want to send parallel requests to the hard disks for different areas of the disk, because it's inefficient. What we want to do is to read 1 packet of frames from one clip and 1 packet of frames from the other clip. But if there is the case that we have each clip in 1 different hard disk, it is more efficient to read both at the same time. Or if, for example, if we are using SSD drives, solid drives, then it can be faster to read from both clips at the same time. You will need to test your particular case. It depends also, some disk arrays behave better in a situation like this and not others. So if we want to read from both clips at the same time, what we can do in config is to activate the multiple disks I/O. So and you will see that it proposes to use double number of threads than pipe units. This is logical because if we have 2 clips and we read from both at the same time, we need double number of threads to process all these frames in parallel. The play and stop functions are very related with this parameter, the pipe units. By default, it is the number of system threads or CPU threads. But the reaction is going to be faster if we reduce this number. We can reduce this value, or we can click on the white area to adjust 1 by 1 for more precision. We can also propagate this value to all the other presets if we want it. If we set a small value, the playback start and stop is going to be faster. This is good for client reviews, editing, the situations that we don't need a lot of performance but fast responsiveness. So why the pipe units is related with the fast responsiveness of the system? Let's suppose that the frames are a liquid you like. When you press playback, the pipe is gonna fill up slowly, but if you squeeze it and make it thin, the frames are gonna go to the other side very fast, the first frames. But if you make it wider, it's gonna take more time, but you are gonna have more frames per second. So you have to choose fast responsiveness or more efficiency. Let's talk about some tricks in still mode. In this example, I can see that when I move the clips or I move the monitor, it takes time to refresh because it's R3D clips. So what I can do to make it agile is to select these 2 buttons, the mute audio and mute video. And in this way, I can see that I can move very easily. It's not refreshing the image, but it's easy to set up, to move clips or prepare everything. The other way that I can do this is if I press the shift key while I move the monitor bar, it's the same thing. It's like if I temporarily switch off the audio and video. And the shift key also works when I am moving the timeline, not only the monitor bar, but when I scroll through the timeline. Another thing is when I zoom out, I see it is very slow because Mistika needs to recreate the icons for the new part of the timeline that is coming into my view. So what I can do is to switch the zoom of the timeline to a small level, so it's easy to refresh because Mistika doesn't need to refresh the icons. So I can go to the place I want and then switch the images back if I want it. In the Edit Setup panel, I have more options for the timeline view to control what the icons are doing. I can select if I want a stripe of images, for example, when you want to synchronize with audio is useful. but these things are pretty slow, so the refresh is gonna be slow. So as soon as I have the synchronization made, it's good to switch off all these options and have only the icons for the beginning, end, and the current position. There is also another button, which is the mute moving clips. When I move a clip, the refresh under the monitor bar is going to create also slowdowns. So if I activate the mute moving clips, I can prepare everything and I don't have to be worried about this problem. Finally, there is another button in the visual editor, which is the feedback button. For example, if I want to adjust animation curves, it's going to be slow because the moment I move a keyframe, the image is going to refresh. But if I switch off the feedback button, I can move keyframes, I can do everything, and it's not going to refresh until I activate it again or I click on another position of the timeline. The render units is the equivalent of pipe units, but in this case, render units is for render. Pipe units is not going to be used at all during a render, because we are also encoding image, so we have also the encode threads, so we have a different situation here. The IO threads is still in use to decode the images that we are rendering. We send it to the GPU, but then we are not using the playout ring buffer at all. Once the effects have been applied, we are going to send the images to the encoder, and then we are going to write those images to disk. Well, this is a bit of a mess. I know that you all love my artistic drawing, but I'm going to put here a proper diagram, more specific for the render case. Here we go. Now we are using the render units to control the disk. We are not using the pipe units anymore because now we have to read and write, so we need separate control for this parameter. The IO threads is still in control of the decoding of source image formats, but now we have also an encode threads to control how we want to encode the compressed codecs. Also, we have some NVIDIA hardware encoders for H.264 and H.265. And the bandwidth intensive formats are a very special case. They depend on the disk speed, obviously, but if the disk is not fast enough to receive all these images coming from the render process, those images are going to be sent to the cache, to the write cache. Then, if this cache is full, the render needs to stop until those images are written to disk and it can continue. Let's do some examples. First thing, we'll need some tools to analyze what is going on. The main tool is the task manager, but also there is one thing very useful, which is to open Mistika in a console. In this particular case, in a Windows system, you can also do this on Linux and Mac. What I'm going to do is to open in the search field or with the Windows key, the CMD. This is the console that we can execute Mistika on it. To make it easy, I'm gonna throw the icon on it. Alternatively, you could type the path to the Mistika application. In this way, we can see in the console what is going on, what is the internals of Mistika execution, which is very useful as we are gonna see in the next examples. In first example, I'm gonna render to uncompressed EXR, which is very bandwidth intensive, so we are gonna see this case. So I press the Windows key to open the Windows bar and click on my console, and also I'm gonna open the task manager that I have prepared there, and has a lot of information about the system activity. As we can see, there is a lot of activity in the hard disk, number 4. I can see that the GPU is not doing nothing. The network, the CPUs are pretty much very quiet. And if I go to the console, I can see all these messages. They mean that Mistika is waiting for writing. It's waited for 100 whatever milliseconds to write frame whatever. This means that our bottleneck is in the disk speed. So in a case like this, the only solution is to use a faster storage or faster connections to the storage if the problem is with the network connection. Now we are gonna add another effect, so this render is gonna change. Now what we see is that disk speed down and the GPU is really at 100%, so this is the new bottleneck. Also, if we take a look to the dedicated GPU memory, this is an important parameter. We are okay because it's at this moment half of it, but this is important to monitor what happens here, because if the memory is full, the graphics memory, then Mistika is going to try to use the RAM memory, the system memory, as for the graphics operations, and this is much slower. If it happens, what you will see is that the shared memory area is going to start growing. If it goes to the top, it will crash. But if you are using shared memory here, what you are going to appreciate is that the Mistika is slowing down. So if your Mistika is fast and suddenly start going slow, this is one of the things to check, that there is no shared memory in use. An even worst case is if it happens with the RAM memory. If we use all the memory, then the system is going to use the hard disk as if it were a memory, and this is extremely slow. This is a radical slowdown. So check the previous sections, because the key thing is not to put everything to the top, all parameters, but the key thing is to achieve a good balance.
Imagine that we have a very big images, like for example 16K or 32K. If we try all these things, like reading frames in advance, having a ring buffer, at the end the whole thing is going to explode in your face, because there is no memory to support all these images. And also the interactivity is going to be reduced, because we are trying to do more than we can.
Another technique that we can use for faster rendering is to choose the right combination of encoding and decoding. In this example, my source images are EXR compressed, which are very CPU intensive. So they are using the CPU not 100% but close to it for a playback. We are now doing a simple playback. And this system is an old system, like 15 years old, with 8 cores. So if we try to render to the same format, we are not going to have enough CPU, and it's going to be the bottleneck. This is a render to the same format, and as you can see, I can get very few frames per second because the CPUs are saturated in many moments. But now I'm gonna do the same render, but using a GPU encoder, NVIDIA H264, and what we can see is that the CPUs are lighter, and I can get near real-time speed, so it's a huge difference. Also, if I check the GPU, it's also at 100% almost, the GPU encoder, of course. So this render is using all the CPUs, most of the GPU, hard disk, everything. So this is a good render for the winter, because it can heat your house in the cold days. A common question is how to prepare a collection of render jobs and let it rendering during the night or unattended. To do this, we need a render manager. So first thing, I'm going to install one of them, the Smedge. We can download from Uberware.net. This is a very simple render manager. It's free of cost for the first systems, and it's very easy to install. We are going to click continue, all options by default, and now it's going to open. Once it's open, system connect. And that's all what we have to do to install it. Now, once in Mistika, we need to press this button, the configuration settings wheel of the Add to Render Queue button. This is opening a dialog to select what is the render manager that you want to use. There are several options. In this case, we are going to choose a Smedge, and that's it. And here we have 4 clips. So now we have to decide if we want just one render with the 4 clips, or one different render job for each clip, which is what I want. To do this decision, you have to go to the Split to Segments section, and the Split button lets you choose different options. As a single clip, by timecode, so it's going to make one render job per clip. By blocks, it's going to create one render job every time that there is a space between two sections. And by selected, it's going to create one render job for each item in the selection. I'm going to use the split by timecodes, because if you see here, we have 4 groups, not 4 clips, but 4 groups. So if there are several source clips in those groups, using the split by timecodes, I make sure that I'm going to split one render job for each original source clip, as there is obviously a timecode jump between every 2 clips. And now we are going to create the render jobs. If you just want to render one clip after the other, you can just press render foreground or background, and Mistika is going to render all the clips. So Mistika can be used as a simple render manager. But for more flexibility, we are going to use the external render manager. So what we have to do is to press the Add to Render Queue button. And now if we switch to Smedge, we are going to see how all the render jobs are coming. And here you can see the status of each render job and the progress bars, which render job is doing each computer if you have more than one computer. You can also stop some jobs or change priorities. You have a lot of options. It's a very powerful software. And also one more trick. In this system I have 2 GPUs. If I move the monitor, I can see that I am using only one of the GPUs, GPU 1. So I'm gonna switch to the desktop. To do that, I can simply press Windows D, and I'm going to tell Smedge to launch in the other GPU, in this case a K5000. Now if I send a new render job, is started in Smedge, so I can check that the render job is running in the other GPU, in the GPU 0. So now I have my GPU 1 available, so now I can work in one GPU while the render is going in the other GPU. This is efficient as long as I have enough RAM, memory, and CPUs for both processes. It also depends on the operating system. In Mistika Ultima on Linux, the background render is using the other GPU automatically, but if you need something like this in Windows or Mac, this is a way you can do it. And of course, you can also do the same with Mistika Boutique. The specific menu can change. It can be render OpenGL on this processor, or it can be something like run on graphics processor, whatever. And also there is an option to configure the default behavior. So just check, depending on the operating system, these menus are gonna be different, but they should be there. And now the most important thing. Once the jobs are ready, all the chickens are rendering, don't keep watching the progress bar. This can lead you to do insane things when you are bored. Instead, rise to the surface, enjoy the sunlight, get a coffee, or whatever.
Did he just say coffee?